paradoxes invite us to question our assumptions and push the boundaries of our understanding. As science progresses, will we uncover solutions to these mind-bending puzzles or only deepen the mysteries? Stay tuned as we continue to explore the unknown. Recent theories propose that information might escape black holes through a surface called the quantum extremal surface within the event horizon. This groundbreaking discovery suggests we might finally resolve this paradox, bridging gaps between quantum mechanics and cosmology. The black hole information paradox. Does information disappear? Lastly, let's tackle a paradox that merges quantum mechanics with general relativity. The black hole information paradox. Black holes consume matter and emit Hawking radiation, which appears to carry no information about what was swallowed. This challenges a fundamental law of physics. Information cannot be destroyed. However, if you try to observe which slit the photon travels through, the interference disappears. This suggests that observation itself alters the behavior of particles, challenging our perception of reality. The observer's paradox. Does observation alter reality? Quantum theory introduces us to the observer's paradox, perhaps best illustrated by Schrödinger's cat, a thought experiment where a cat in a box is simultaneously alive and dead until observed. This dual state demonstrates that simply observing a system can change its outcome. The double-slit experiment adds another layer of mystery. When particles like photons pass through two slits, they behave as waves, creating an interference pattern. Here's the question: who actually wrote Hamlet? This paradox has been a popular theme in films like Doctor Who and Terminator. Another example involves traveling back in time to stop World War II by eliminating Hitler. If you succeed, the timeline where you had a reason to stop him no longer exists. Does this create a new, unintended timeline? Or does time itself prevent such paradoxes? With recent UFO sightings and the ongoing advancements of telescopes like the James Webb Space Telescope, perhaps we're closer to finding answers than we think. The bootstrap paradox. Who wrote Shakespeare? Let's jump to a paradox straight out of science fiction, the bootstrap paradox, which deals with time travel. Imagine buying a copy of Shakespeare's Hamlet, traveling back in time, and giving it to Shakespeare himself. He publishes the play as his own. Over centuries, Hamlet is reproduced until a copy ends up in the very bookstore where you first bought it. Originally formulated in 1961, the Drake equation was developed when no exoplanets were known. It wasn't until 2020 that astronomers, using data from the Kepler Space Telescope, discovered over 300 million planets with Earth-like conditions throughout the Milky Way. Their analysis indicated that approximately half of the galaxy's sun-like stars possess rocky planets in habitable zones where liquid water could exist. In fact, planets are incredibly common, outnumbering stars in our galaxy. Some argue that the Fermi Paradox isn't a legitimate paradox because we can only speculate about the existence of intelligent life beyond Earth. However, the Drake equation is often referenced in this context to estimate the number of potential civilizations in our galaxy. This equation uses 7 variables to assess the number of detectable civilizations in the Milky Way, suggesting that there could be millions of Earth-like worlds hosting intelligent life. Let's explore. Many of you may already be familiar with the Fermi Paradox, named after Italian physicist Enrico Fermi, known for creating the first nuclear reactor. This paradox poses the question, where are all the aliens, given that our solar system is relatively young compared to the universe, and that a civilization could potentially achieve interstellar travel within this time frame? We would expect to have encountered some form of extraterrestrial intelligence by now. The human brain is one of the most intelligent entities on the planet, yet there are concepts that elude our understanding. One such concept is the paradox. While we've evolved to perceive reality in a certain way, paradoxes challenge our assumptions about how the universe actually functions. Recently, some physicists believe they may have resolved a 50-year-old paradox, but is that truly the case? And what are some of the other most intriguing paradoxes?